Good morning, everybody. Monday morning, 10 a.m. And we're going to start out with a session on WebAssembly. And I'm going to focus on, as I said, run, extend, and secure your .NET application with WebAssembly. First, it's always polite to introduce yourself. Big picture on the screen. So my name is Niels Tanis, and I work as a security researcher for Veracode. I have a background in .NET development. I started out my development career in the early 2000s with the first bits of .NET. And I always did security on the side because it was a lot of fun to do. And then in 2015, I joined Veracode, where I mostly focus on what we do for static analysis for .NET. I'm also doing a lot of Rust. You're going to see some Rust today because Rust and WebAssembly are really, like, they mingle a lot. There's a lot of stuff that's good. I'm going to show you, and I also do a lot of public speaking like this, and that's why I'm Microsoft MVP. I'm proud of that. Developer technologies. It's always good to tell how stuff is broken, but it's better to talk to people on how to build better stuff, right? That's my goal. That's always what I try to achieve. And hopefully you can get something out of it today in relation to WebAssembly. And it's nice that we have like a bit more time. This is like 60 minutes-ish. I tried to squeeze it in so we have some time for questions at the end. If we look at WebAssembly, the MVP, but then minimal viable product, was released in 2017 in all major browsers. It was supported by all major browsers, right? And it's like a binary instruction format, how this thing says, on a stack-based virtual machine. And it has to be seen as a portable compilation target. The right ones run everywhere, right? That's the analogy that they used. So that was when it was firstly introduced. The major browsers got it. And what was the first thing we saw happening after that point? So when I was doing my university time, there were also like engineers. They work with AutoCAD, which is a designer like tool that allow you to do drawings on buildings and constructions and that kind of thing. So AutoCAD is the company that has, or Autodesk has got AutoCAD. And what they've done is they've taken their existing C code base and use a tool called Mscripten, which you're going to see a couple of times during this talk. And they compiled it into WebAssembly, allowing you to run the tool inside your browser, right? Which is, I think, is pretty cool. This is the first thing. I think Adobe did the same with Photoshop and all the other stuff. There are several of this, but it allowed them to just take that existing code base and run it inside your browser, and that's pretty cool. The wave we saw after that, because it's a portable compilation target, it can also be really helpful to become an SDK for SDKs, right? So both Disney Plus and Amazon Prime, right? Those are the streaming services. If you look at the app of Disney or Amazon, you will see that they all look familiar across all the devices. For example, Prime can target 8,000 devices all at once because they use WebAssembly as their target to compile. And it's just like the composite view of all the stuff you see is all the same. But it will be compiled against different media boxes, like maybe your television services in your country will have a different box that needs to run it, right? Those are all the things that they achieve with using WebAssembly as their target. And the same counts for Disney Plus, right? They allow others to integrate it into their technical stuff based on the development kit that they created, right? So that's pretty powerful using it as an SDK for SDKs because it's a portable compilation target. So this was the first wave of WebAssembly. Now let's move to what happened with .NET, right? So I first want to briefly introduce some designs and some internals and some of the things why I think WebAssembly is secure and how it works and how it's built up. Then we're going to run some .NET on WebAssembly. You can probably figure out what that will be. And then we're going to focus more on taking modules and running it inside a .NET application by extending it. And then at the end, that's close to what I like about WebAssembly as well. There's a lot of security features you get for free, which you can leverage. And that's what we're going to do at the end. So I have several demos. The slides will be in PDF in a repo at the end. I will share a repo that has all the demos, all the scripts that I use to run it. So don't be, you can take pictures, of course, I don't mind, but I will share it at the end. Only just before this talk, I realized I didn't put the PDF in yet, so I will do it after the talk. But you will have the notes version as well. I'm referring to articles, and those have links, and those are in the notes. So it should all be there. Don't worry about that. WebAssembly design. What makes it WebAssembly? What were the main basis principles they took upon when they started out doing this? It needs to be fast, efficient, and portable, right? So even if you target a specific device, it needs to run quickly, right? If you run inside the browser and if it's, say, responsible for rendering media or video, you want it to be performant. You don't want it to be slow, right? That's the thing. It also needs to be readable and debuggable. If you look into WebAssembly modules yourself, you will see that it's a bytecode structure, but there's also a textual representation of the same things. And it's built up out of some primitives, but you can read through it. It's that state machine you see inside that file. It also needs to be kept secure in the sandbox. And running stuff inside the browser, if you're running stuff on the website, you probably can rely on the same origin, right? The fact that something comes from an origin, you grab it from sveduk.se website, that will be the origin. So that will be the constraint you can communicate with. But there's some other things involved with that. We're going to get to that once we talk about the securing part. And also the backwards compatibility. I think in the old days when we had the browser wars, nobody with their browser, and there was like Netscape and all the other old things like Internet Explorer, they don't want to break the web. And if you would have changed the browser to behave differently, you would have lost your user base, right? And from security perspective, compatibility is always the killer in that angle. So WebAssembly definitely had the goal to at least not break stuff, and it kept it working. As I said, it's a binary instruction format, and it's similar to how we run .NET on the CLR. It's a virtual machine type of thing, or how Java, the JVM, runs its bytecode. And it's been designed as the portable compilation target. So you just run it, and you can run it. If there's a runtime on a device or on the piece of hardware, it will execute, with some constraints, of course. Some of the other security models they introduce is that they want to protect users from buggy and malicious modules. And we're going to get to that in a bit. But the nice thing is that a module will be on its own once it's loaded, and it will be constrained on what it can do and what it can achieve. And that's what they were able to do with that. And they also wanted to provide developers with useful primitives, meaning that doing the right thing should be easy. And if you want to do something that might introduce issues or security problems, then it should be hard, it should be explicit. I think for .NET, the analogy I always use, if you suppress certificate validation, it's pretty, I think it's even containing dangerous, right? If you put that handler in it, that's not a good thing to do. So you want to have a good default, and if a person needs to do something else, it's good that the API call will be explicitly saying you, like, hey, are you sure that you want to do this? This might be dangerous. So those were like design principles that they used for WebAssembly. And one key essence component of WebAssembly itself is the way how it deals with memory. So I'm using a lot of blue drawings here, which are code cartoons, and those are created by Lynn Clark. She's part of the Bytecode Alliance. She has a whole series on where she explains technical things, and a lot of WebAssembly drawings, of course. Those are nice. If you see that blue drawing, I just copy it, the sources in the slides. If we look at a WebAssembly module itself, once a module gets loaded, it will have a chunk of memory, and it can only access its own memory. It's not, by default, not allowed to access any other module's memory, right? And it's just an array of sequential bytes it can access, and that's it. That's where it stops. And that makes it quite secure, right? If another module wants to access data that belongs to something else, that's not going to work, unless you need to do something about it. So this makes it, by default, really secure and isolates what a module can do with its own memory. Doesn't necessarily mean that a module could not do bad stuff. Let's say we found a logical issue or a security problem inside a module. It can still mingle with its own memory. It can still do bad stuff with that. So on top of that, we need to have something else in place in order to achieve more secure, like at least more guarantees. I think that's the right word, because securing a system, digging a hole, putting it in, put a lot of ground on it, then it's secure, nobody can touch it. That's not how it works, right? You want to have something that works. The thing that they also do on top of it is something called control flow integrity. And I was thinking, like, how can I explain it to this? And then I'm a C# guy, so I'm going to do a code snippet to explain to you like what it is. So if we see this code path here, and it's just like reading a number, it writes it out, then there's a conditional check done, right? If else, and then at the end we're done at the end with writing down the last line. This is we can chop this code up. We can create blocks out of it. We can put it in blocks like this. We know the first bit will always execute. Then we will have the choice based on what the value is of the numerical thing that's read, and it will be either the left arrow or the right arrow that we're going to follow. And then at the end, we're going to get to where everybody stops, right? That's the last statement that will be made. You can see this as a map of execution, of possible execution paths. And control flow integrity does give you that So at compile time, it will determine what the execution flow will be. And yes, there's always the exception, but for the basic stuff, this will work. And once it diverges from that, it will panic and it will stop executing, right? So that will at least give you the guarantee on top of the module memory access that it won't do any bad things. And you could also question like, okay, but this concept, this is all conceptually, how good is it? So who in this room relies on or uses Firefox as their browser? Okay, so I'm using it a lot because I think there's some real good isolation in it happening. But one cool thing about it is that Firefox has got a project that they call RLBox, which heavily relies on the language features of WebAssembly. And this is really cool. So in the old days, if we had browsers and if we had media stuff being rendered, that's like C, C++ code. What happens with C++ code in the old days? Somebody found a security problem like a buffer overflow and could execute stuff inside the browser. And we had no process isolation, right? Everything got access to the single process of the browser. You could take over the system and all bad stuff happened. So in combination with, I think it was a University of New Jersey, they started out this project. And what they did is they took some of the plugins that run inside Firefox. They took that existing code base and they converted it into WebAssembly, getting all the features I just talked about, right? So control flow integrity and the isolation of the modules and the memory from that piece. And also still high performant. But the thing that they did then afterwards is that they didn't want any WebAssembly modules to be shipped part of the Firefox binary itself. So then they took a tool to convert it back to C++ based on the language construct. So they leveraged the fact that WebAssembly gives you that control flow and all the checks at compilation, and then they mold it back into C++ and put it inside the browser. So technically this relies on how good WebAssembly is, and they put it in. And everybody who uses Firefox is relying on this right now. I think it's pretty cool. The other thing that they also do is they isolate the modules in such a way, like if you have a black box and you use a module, bad stuff will happen if you put stuff in it and if you get data out of it, right? That's a boundary. If I look at static analysis, it's all data flows going through your application. Like, hey, this is data that's read from the user and then it's used to construct a path variable that's read from the system. Then I've got file access. I can do bad stuff with it. So what they also enforce is they made it explicit that data that comes from the plugin or is being put inside the plugin needs to be vetted in order to execute. And that all adds up, right? So this is pretty cool. Everybody relies on this if you're running Firefox, and it's relying on WebAssembly and how it works internally. And then they compile it back to C++, which I thought like, okay, that's funny. That's just cool stuff combined. So this all said, there's a lot of goodness in WebAssembly, how it works, how you can use it. Now let's look into how we can run .NET on top of WebAssembly, right? I think this was a picture I took from, I think it's Ivan Tolson, who works for Fermion. He has a nice presentation on .NET and WebAssembly. And he illustrated like, hey, if we have a code base like this, we write our own user code, our own IL that we compile. We have the standard library that we rely on, system.io.file, for whatever reason. Then we have the execution engine at the bottom, which is the CLR that takes care of the .NET runtime starting and executing your code. And it will run on top of a host, right? How can we get this in a WebAssembly context? We can say, hey, let's replace the execution engine with something that runs on WebAssembly, and then we can run it inside the browser, right? And you probably know exactly what I'm talking about. This is, of course, how Blazor works, right? So what they've done is they've taken the parts of the CLR, use a tool called mscripten to create the runtime. You still have the .NET DLLs yourself if you compile. If you do a .NET new project, I'm not going to bother you with that, but you can. The first hit, you will see all the, now it's WASM files, and in the old version it will DLLs, they will download it to your system, right? Then the .NET CLR starts, and then you can execute. And there was a file that was the bridge between the browser and the application itself, right? In order to be able to poke and say, hey, I want to open a file, you need to instruct the browser to do that. I believe that's the part that's done by the JS bridge over there. But this is how it works, right? So, and if you use Blazor, then and this is how it runs. Pretty cool. What if we want to take this stuff outside the browser and still rely on the fact that we want to run our .NET on WebAssembly, but I want to replace the browser part with something else, and I want to run it as on the server, right? And that's exactly what was done with the release of something called WebAssembly System Interface, or WASI, and it was introduced in 2019 by the Bytecode Alliance. Right, so the Bytecode Alliance is a group of people. I think most of them started out at Firefox. Some of them right now are with Fastly, doing lots of WebAssembly stuff. Microsoft is involved, some of the bigger ones as well. They had the goal of creating that as a standard, right? And they also created a runtime, because in order to run WebAssembly, we need to have a runtime that helps us out. And WASM time is the one that they created. And we're going to look into WASM time in a bit as well. And the first goal was it needs to be a POSIX-inspired, engine-independent, non-web, system-oriented for web API for WebAssembly, right? Taking out the OS, we need to talk to something else, right? And that's the WASI interface, and it looks something like that. The additional things that they wanted, and now I got really excited when I saw that for the first time, is like it allows us to do capability-based security in a sandbox, right? You can take out stuff that you don't want the module to do. Or you can say, in order to do this, by default, the WebAssembly module has no access whatsoever. We're going to see that in a demo, but you need to explicitly grant it access to do stuff. Or you need to grant it access to do requests to the web. Pretty powerful. In Preview 1, and most of my first demos will be based on Preview 1, but the concepts are still the same. They focused on file system stuff. Preview 2 supports a lot more. The .NET tooling is not there yet. We're getting close. 2 weeks ago, Bytecode Alliance also released some tools, which I'm going to show you at the end. The whole WASI SDK, we're going to touch that, is also heading into the right direction. To me, it almost feels like, hey, once we had the .NET Converge, right? We had Net Standard to help us out, unifying the whole BCL in between. This feels almost like, hey, WASI is that BCL that everybody shares, and everybody can just write their own language on top of that, a module created, and then just run it, right? Because it will just work, and I think that's pretty cool. And you could then question, like, how important is WASI? And this is a tweet that everybody always uses in their talk if they talk about WASI. So this is a tweet by Solomon Hykes, or X, we need to call it nowadays, right? And he claims, like, hey, if it would have existed in 2008, then there should be no need for us to create Docker. And he probably got a lot of angry comments when he said this. I believe at this point he was not actively working with Docker anymore, but he's just like, hey, WebAssembly has a bright future, and that whole standardized WASI layer, that's the one we needed in order to move forward. The next day, he had another tweet on X saying, like, so will it replace? No, but it will be something that runs side by side, right? It will be something different. The container is a bigger thing, and a WebAssembly module can be really small. And that's the difference, right? And therefore, it's something that you can use both ways. And exactly that's what we saw later on with Docker, right? They said, I think this was KubeCon maybe 2 years ago, or Cloud Native, I don't know, 2022. They introduced it, and it allows you to run WebAssembly modules on WASM Edge, which is also like a WASI compliant runtime. And you can do the same as with containers, right? And I think this is pretty cool. So getting there, in total, if we want to do this, we want to have the execution engine still running in WebAssembly, and we want to have a host that runs WASI. And in this case, it's WASM time. And then the person who also brought us Blazor, Steve Sanderson, showed us this. I think it was like 2 builds ago, where he said, like, hey, we have a WASI SDK, which is like an experimental thing. And with .NET 8, you can also install it yourself as a workload. But it allows you to build a console app which runs on WASI, and that's exactly what we're going to do. And I think this is the workload you can still install right now if you want to do it. But let's move to some code. Let's see if we can get the stuff running on Monday morning, or if the demo gods fail. Should be fine. I did my homework, but let's see, you never know. This is not the one I want to go in first. Hold on a second. Let me open up this folder. Once you have the workload installed, you can create a new project, right? Is everybody able to see this, or do I need to even zoom in a bit more? I can do once more, but then I might lose some characters, but let's see if this works. If you create that project, right, you will see you have a project type, and the runtime identifier will be different, right? It will say, like, hey, I'm running on WASM itself. And in this case, what I'm doing here, this is the default demo you always see everywhere. Just throw in the architecture of the OS you're running on once you start executing this, right? If we then do let me clear this one out, a .NET build, not in this case, let me exit once more and open a new console. Yes, .NET build should be here. If we build, we see that it has built a DLL, but it has also built a WebAssembly module. And if I then say .NET run, you will see over here that it starts, in this case, the WASM app host, and underneath the hood, it will take a WASM time, and it will execute. And it says over here, I'm running on WASM, right? So hello, good morning to everybody here. We're running from WASM. If we want to run this on my native machine, I need to do a publish because some of the templates has changed. So right now I'm saying compile this binary to my local machine architecture, which is an M2 Mac. It's building. If I then say execute this, you will see it will say hello from ARM64, right? So that's the difference, right? The other one runs on WebAssembly, this one is on my machine. So now let's start to do stuff with files, because as I said, with Preview 1, there is stuff with files we can do. So let's say if we want to access, within WebAssembly, we want to access a file that's on my system. I'm going to say file, read all text. Let's say I want to read a file on my local system called etc hosts, which has nothing of value in it, hopefully. And then let's write it out to the console so you can see it. So make sure we save it, and then see .NET build. If my fat fingers didn't fail me, it didn't. And if I do, then let's clear out before I do the .NET run. And it will fail miserably, because right now it tried to open a file. And as I said, if you run stuff in WebAssembly, by default, it has no access to it, right? And we need to grant access to it. And that's something that we can do. Over here, you see that it run. In this case, this is the thing it runs. If we go to the bin debug output, you will see there is a net8, and I think there might be a WASI and the other one, yes. There is a WASM file over here, .NET WASM, that's the runtime, right? That's the CLI that executes, and there are the DLLs that we have. And right now, if I execute this command, right, it says you have no access. But what you need to do is I need to inform the host, the WASM time in this case, so like, hey, I want you to be able to read the etc folder as well. I need to grant it access in order to achieve. And what you see then is that it will have a pre-open directory, and it will allow the runtime to get that file, right? So that's pretty powerful. If I then look into the one that I created before, right, doing the .NET publish again for my Mac, for my own machine, and if I then run it, you will see it will just say, hey, I will just give you the files back. I don't care, because everybody can run this, right? This is the process, and there's no runtime in between that allows you to have access or not. So this is the first bit, right? In order to do stuff by default, you cannot do it. You need to instruct the runtime to allow access. And this is like, okay, Niels, this is a cool demo. I've seen it a lot. Let's take it to the next level. So my next slide explains about what can we do to extend, right? We can run in this manner, we can do stuff. And as I said, this is preview 1. I'm going to get to preview 2 at the end. You will see a bit more advanced demos. But let's now move to an extension demo where I'm going to do the same bits and pieces. It's called extend. And first I'm going to show you some Rust code. So I have a module that I wrote in Rust, which is, I cheated because this is just a default demo you get if you do this stuff. But what it does, it copies files, right? We're going to get to files again because we want to have control over what the module is allowed to do or not. For people familiar with .NET, you probably recognize like, hey, this is just a main method, same as you do with C#, right? It reads arguments, and once the arguments are being put down, it says like, hey, I'm going to copy files. And that's exactly what happens here. It opens the files, copies the content, and then puts it into the destination. This is compiled into a module. And that module we're going to consume in a host app. And let me open this project. And is this the one? Yes, it is. So this is just a default project. But what I've done is, the cool thing is that WASM time the team also created a package that allows you to run WebAssembly inside your app, right? And as I said, I want to extend my .NET application. And yeah, there's a lot of ceremony in this, but Preview 2 will make it a lot easier. But this is just to show you what you were capable of doing. WASM time can be run, for that matter. And now what we're doing here, there's a lot of code, but I'm going to talk you through a bit, is I'm instantiating, I'm doing some configuration because I want the standard input and output redirected to the console. I'm going to pass on the arguments, then I'm going to create an engine to execute and do some stuff with linker. Then I'm defining, hey, I want to use the WASI layer as well. And then I'm loading the module. This is the WebAssembly module I compiled from that ROS project you saw before. Trust me, it's exactly the same. And then we're going to load it and we're going to instantiate it. So nothing fancy, right? And this is then doing that for that thing. So let's make sure I'm in the right folder because that's not the right one. This is, if I now say .NET build and .NET run, it will give us, hey, you need to use it like this. So this is the console app itself, and this is the WebAssembly module that was written in Rust, right? That runs inside my .NET application that we're using right now. So you need to say, hey, I want to copy my etc host file to hosts locally. And luckily, in this case, we're not getting a big stack trace. It explicitly tells us, like, hey, right now you're doing stuff that by default you're not allowed to do. So let's instruct our runtime to do it, right? So right now, let's see if we're able to get this working. So with the console CLI I just showed before, you just put it in as arguments. Right now, I can just do it programmatically, and I can say, okay, I want to have access to the etc folder. I want to, and I want to also map it to this one. By default, you can also do virtualization, right? That's pretty powerful. It almost feels like a container to some degree. And you can say, I also need to grant it access to the current directory of where the process is being run from. By default, it has no access. So let's do it straight away. So if I now compile this, right? The only thing I changed was the fact that I want to grant it access. And then say .NET build, if my fat fingers didn't fail me. And if I now say .NET run, doing the same, it didn't give any error. Did it succeed? Yeah, so it copied the file from my system and put it there, right? So this is almost the same as we saw, but in this case, we've taken the runtime inside our web application or inside our .NET application, and we're using it from that perspective, right? It's really that composite feel to it. Can we do more? Oh, yes, we can, right? So the cool thing about WebAssembly itself, so there is a concept called fuel and consumption. So if you do long-running operations on WebAssembly, you will use X amount of fuel to get there, X amount of ticks. And I think it's just a logical unit. It doesn't necessarily mean that there's like one operation executed, but it will have a balance. And you can say, okay, I'm pretty confident that this module needs to execute between this bounds. And if it exceeds that bounds, then there might be something wrong. And that's another additional layer of defense, right? So let's see what happens if we enable our engine to say, like, hey, I want to limit the amount of compute that it can execute. I'm not going to put it on 250 because that's going to be too little. I believe 50,000 should be enough. And then at the end, show me what are the amount of ticks or fuel you have consumed, for that matter. So let's save this. Let's do the .NET build again. And copy. And right now it says consumed fuel is 14,000 in total, right? So 50,000 is definitely enough. So let's say for certain you know from previous runs it needs to run and it needs to complete within 5,000, which is not going to happen, right? But just to show you what will happen if you do that. You can say, okay, .NET build, did I save it? Let's just close it to be sure. And if I do another run right now, let's call it hosts 2, it will throw a panic, right? It will just give you a lot of errors, but it will say, hey, trap, I've stopped executing because I've exceeded the amount of compute that I'm allowed to consume. And even with memory, you can consume, like, you can say, hey, it only is allowed to do X amount of megabytes or gigabytes for that matter in order to run. So if a module becomes malicious or if stuff happens that you're not expected to happen, you've got the ability to limit it, right? And you can do it right now by extending, and these are all parameters you can also instruct on that WebAssembly, on WASM time, runtime itself. Right now we're only doing programmatically, and I think that's powerful. When I was looking into it, like first time I want to extend it, this is a way, right? So let's move back to the slides and let's continue where we're at, because what we have seen over here is the next demo I put in, right? So this is what we have done. taking a WebAssembly module and run it, right? And it doesn't matter if it's written in Go or Python or whatever. You can just run it in that same situation. In my demo, you also find one which is using Python as the module, and then it will do exactly the same. But what will this result in, right? What will we able to do? I'm going to move a bit to more like trusted computing and cloud compute, because everybody probably is familiar with XKCD. Those are like the nice drawings. SQL injection, that's the one that everybody uses if they talk about security, like your surname is drop tables, right? That's the thing. There's also one on the whole dependency stuff that I've used a lot. But if you look at the modern technology stack and all the layers you're involved with, if you're doing cloud, if you're doing stuff on Azure, on AWS, or Google Cloud, then you've got several layers that can be compromised by a current employee or by Bitcoin miners or maybe some foreign government in the lower parts where hardware has been compromised for certain reasons, right? This is a whole variant of different like layers of threats you need to be aware of. And cool thing is that I think this was some people from Red Hat started out a project called Anarchs, and they're doing confidential computing with the help of WebAssembly. And what they're doing is they take a section within your hardware, which is called a T, or Trusted Execution Environment, that will allow you to execute modules that are WebAssembly WASI based. And that's cool, right? So if you write stuff in .NET, you can do that on Anarchs, and you can do confidential computing with it. So that's pretty cool. And this is one drawing they use themselves, right? If you see all the layers, this is like the trap model. I don't trust the host, I don't trust the host owner, right? I'm pretty confident that both cloud vendors, all the cloud vendors do the best they can, right? But if you're really paranoid or if you have a lot of stuff at stake, you probably want to have a risk model that justifies the stuff you're doing. I want the hardware to be cryptographically verified. So each of the chips have some signing stuff with certificates and private keys that can be audited. And what they also do with Anarchs is that it's based on WASM time, but it has certain checks in it. Everybody can review it, it's public, so you can just go to the repo and see how it works. But it will also do some attestations once it starts out. Is the timing right? Does it take a long time, right? I think that's cool, and that helps out to cover a lot of the risks. And then, this is another drawing, but you will see like, hey, I have an application that runs on WASI WASM, and it will be close to the hardware. Even the host won't see the data that's inside. It will be encrypted, and that's all because the project that facilitates it, but it will be done based on WASI. I think that's pretty cool. You just get it. If you compile to a WASI compliant module, you're able to run this here. And how big is it, right? This is Anarchs. So I think it was 2 years ago at Build, Mark Russinovich showed this, where he talks about Project Hyperlight, which is we've got containers, we've got virtual machines, and now we see the same stuff that Docker did, right? And we have WebAssembly modules that we run. And Microsoft focuses as well, I believe the project is still in progress, they focus on running on the hypervisor. And hypervisor can give you a lot of security guarantees. And when I was starting out with WebAssembly, I think I was talking to Steve Sanderson at some point, it was NDC somewhere, and he said, like, yeah, you can isolate stuff and you can limit stuff that you're allowed to do. And in that same year, he showed something called .NET Isolator, where he takes .NET and runs it on WebAssembly inside of .NET. And then he claims, like, why do you want that? Yeah, because you're able to do it, but it will give you the ability to control of, hey, if you grab something from the net or something from an untrusted source, you can more safely execute it. And the other one, the right-hand side, is WASMCon. I think it might be 2 years ago. There's one of the developers talking about why it's important to have a hypervisor underneath WebAssembly, what makes it more secure. So this definitely shows us that WebAssembly is much more fine-grained, it's much more smaller, and will allow us to run cloud compute in a more secure way. So we've seen WASI, we've seen some stuff, and in general, what will be next, right? And this is another series of Link Clark's cartoons, what we're going to talk through and see where we're at right now. So on average, 20% of your app is the code you write yourself. So you can argue like the other 80%, is it really stuff you use, or maybe it's a small chunk of it, but a big chunk of the stuff that you rely on is something that's written by somebody else. And I'm doing it because I'm lazy and I want to gain productivity, right? I don't want to write stuff myself. That's just a given fact, right? There are several studies that show us. if you look at modules and what they have access to, let's say even this is the same for .NET, but if you have WebAssembly modules, the top one will have access to resources. And then if you add a dependency or a module to your project, 9 out of 10 times a module never comes on its own, or a dependency, right? If you grab a NuGet package, you always have a transitive tree of stuff you get with it. You pull that one in. And by default, it will have access to every resource, and it will just be granted access, right? So what happens if a module becomes malicious, right? It gets a mask. I like this drawing. And it says like, hey, aside from what I'm normally doing, I'm also going to look into the file system and grab some more data off of it. This is not what you want, right? This is something you want to have more control over. And the other thing would be, hey, if there's a vulnerability found, so somebody externally can control a module and allow it to do stuff that it wasn't not intended to be doing, right? How can we safeguard this in a better way? Process isolation, right? I talked about browsers before. If you have multiple tabs, and I know that there's like a whole different story behind it, how it works, but 9 out of 10 times a website will draw stuff in its own process, and the other tab will have a different process in order to isolate stuff from each other, right? So if you want to have two things and run it separately, you can have two processes with their own modules and their own memory. And then in order to communicate with it, you need to have some communication channel, right? In the browser, there's an IPC that will, like, that's a communication channel that every process will use to communicate with each other. But this is, because it's across a process boundary, it will be a lot of overhead. And is that the right thing? Because with WebAssembly, as I said, it's much more smaller and fine-grained. We need to have something like, we don't need to have big processes. We can just do a smaller piece. And then over here is the disclaimer, this is not drawn in scale. But we can do something like a nano-process, right? And a nano-process, that's a concept that they started out talking about after they released the first preview. And it would allow somebody to do sandboxing, and this is where my security heart says, like, yes, I can say to a module, you're only allowed to do this, right? You're not allowed to access those files. You're not allowed to exceed this amount of memory in order to execute the stuff. But there's somebody in charge of granting access. And we still rely on the fact that a WebAssembly module only has access to its own piece of memory. But we want modules to communicate with each other. We need to have data that needs to be exchanged, otherwise it's going to be unworkable. So we need to have something like an interface type that will allow people to transit data in between. But there's still somebody in charge, right? If you want to have data, it will be copied. Interface types, that's how they call this. And then if you have an interface which is well written and holds the WASI interface, then you can use really fine-grained access control on those APIs and say, this is what you're allowed to do, and this is not what you're allowed to do. Resulting in the whole thing that, hey, we have the main process that starts out and says to one module, you're only allowed to do this, and the other one you can only do get random, because that's the only thing you need. It gives you more control. And that's exactly how something evolved into the WebAssembly component model. And this is once again a WASMCon presentation you should watch if you're interested in it. Luke Wagner from Fastly explains like, hey, why do we need this, this component model? And getting there, and as I said, WASI itself was 2019, so in 2024, so that's 5 years plus later, January of this year, they finally released Preview 2. And which is a major milestone, because it, aside from all the basic stuff you saw, there's a lot richer stack that you can use. And they also were able to create a component model with all the tooling, because that's the key, right? I think that the biggest essence in this, all of this, is you can put in a lot of complexity and make it really hard to develop stuff, but that's not going to help you, right? Maybe that's even going to be the adverse thing in making a system secure or not. So Preview 2 was released, and that was pretty cool. Another thing that they also released is a component virtualization thing called WASI Virt that allows you to take a component and limit its capabilities, right? So let's say if you run a piece that's on an IoT device that's somewhere in the infrastructure that also runs WebAssembly, and you want to have it give it access to a file system, but there's no file system. With WASI Virt, you can create a virtual one that's embedded inside of it, which will still act as a file system, but it's not there, right? Or you can say, hey, you're allowed to access random, right? This is the whole capabilities thing you can implicitly do. But the cool thing is that you put it inside the module, so it's compiled into it, right? This is just a given fact. And I think looking at good primitives, and as a developer, you should probably be able to decide, like, hey, this is something it would be allowed to do, or it won't be allowed to do. And on top of that, and this is a project that's right now being run by some Microsoft people as well, we have the WASM Components SDK. And they're like experimenting right now with getting Preview 2 components, because you saw all my ceremony with all the stuff you need to do yourself. That's not going to help you, right? It's not going to get you to the productivity level. So this is the thing that Microsoft is doing. And the Bytecode Alliance, I think 2 weeks ago, showed a thing called componentized.net, which allows you to simplify using components, right? And that's the whole piece of getting all the pieces together. I have a module. I'm not necessarily interested in how it's written or in which language it's written, but I can just use it. Let's say there's business value in it and it's being developed by another team. You could just take it and integrate it. And the tooling, there's a piece of library and with interfaces that will allow you to go through how it works. And as I said, I was like pretty keen on getting a demo of this in, but right now it only runs on Windows. And you see, this is not, I have no Windows machine over here. I can do virtual machines, right? Don't get me wrong. But I didn't get the time in order to get this running, and it's limited to that. So unfortunately, the last demo I'm going to show you is based on Cargo Component, which is almost similar tooling for Rust, but it will have similarities on how it will work with .NET. And I can quickly show you the componentized website, what they're going to do. I think this is the one I have here. Let me zoom in a bit to make sure. So what they're aiming on doing is that you could just have, like if you have a component, you need to have an interface type, and it's like a WIT file, that's how they call it. You have a definition, and then the tooling will help you, and you will have the code generated for you, and you can just use it, right? So let's say you have a calculator component, for that matter. You can just call it once the code gets generated, and that's what they want to achieve with this. So I'm definitely keeping a close eye on this one to replace my last demo. But as I said, right now we're stuck with Rust for that. So let me go to another folder I have here. So as I said, this is like the whole project structure that's within the repo. There also is the .NET on WASM on .NET demo I created myself. Why? Because you can do it, right? And there's the isolated demo that Steve Sanderson showed for that same reason. I have the Python demo that does the same. And then now we're going to look into virtualize. Let's see if this is the one that I want to open. Yes. So the cargo component, that's what you do. I'm not going to bother you with how you can create the project. But then if we look inside, and you will see with the .NET one with .NET componentized, you will have the same. You will just say, hey, I'm exporting this thing, and I'm doing this operation in this case. And this is just relying once again on copying files, because that's a demo that we can see happening, right? But this is a component as well. It will export the types that has been defined, and over here there's even a WIT file, I believe, that will just show like, hey, this is the world. We only want to do a CLI. We want to do that package, and that's what we want. So this is almost the same we saw before. So if I run this, let me make sure I'm in the right folder. Hold on. That's here. So with all my demos, I have a markdown file that will describe exactly the commands that I'm executing, because sometimes the demo guards will fail you, or you forget the command, or you just put the wrong one in. So this is the first command, which I'm going to take the first data file, not the v2, but the other one, to execute, right? And if I'm running that, it will just take the WASM file and it will try to copy the same operation we saw before. And once again, it fails, right? Because we have not granted the access to the file system. And that's, of course, that's something we can just do by typing, hey, you're allowed to access your own directory, and you're allowed to access etc. And then we will see if we'll copy the file. So this is the component Preview 2 that has the same behavior for that matter. What if I'm developing this component and I'm giving it additional functionality? And that's what I've done in V2. If we then look into what's happening here, let me collapse this a bit so I can explain it to you. I put in a condition where I say, okay, if the argument starts with HTTP, I don't want you to copy a file, but I want you to go on the internet and grab this content from the internet, so this URL, and do an HTTP GET for that matter, which in the context of a server might be a problem. If this is done on a server based on logical paths, and I've seen it, it might result in something called server-side request forgeries. I can grab data on services where I'm not like supposed to be going, right? Because I can instruct the web server to go to the other web server to grab stuff. And that's a security problem. So let's say somebody introduced this, and we want to run this. I've built this one before. It's the same, and I'm going to copy that command again because I'm going to fail miserably. Hold on. Over here. This is the v2. And if I then want to execute the command and just copy file 1 from file 2, right? That's the previous functionality. That didn't change. We will see that it didn't do anything. And let me just delete the file because it's not saying anything. Hold on. And this is the v2. Hold on. I need to do the v2. This is the other one. v2. It will fail. And why does it fail? I introduced the use of HTTP stack in that module. And by default, it has no access to that stack. You need to instruct it in order to do HTTP. So let's say you have that malicious module you saw before in the drawing, and somebody introduced more functionality in the library. By default, it cannot do it unless I grant it access, right? So if I then, this is just copying files, because it's part of the execution path, it will check that first. So I need to give that explicit access saying, like, you're allowed to do HTTP. And if I do this, then the file will be copied. But if I then go to a URL instead, let's just type it, if I can see if I've got one in my cache. Sweatuk, I think that's not the one, this is the one I want. You will see, if I have connectivity, and it says, hey, it got status 200, it will be able to grab content from the internet, right? This is, if you go to the Sweatuk website, this is the first response you get, right? But by default, it cannot do it unless I instruct it to do it, right? I think that's the power of doing this. And people who are familiar with .NET and have been developing in the early days, can somebody recall code access security? It had similar things to it, right? You need to have origin and some other stuff involved in order to grant access to stuff. Unfortunately, that one was maybe a bit too early, and it was also broken by default because you could just flip a mutex in memory and it was gone. But the concepts were the same. And it's unfortunate that it made it through. But this is showing like what will be the next thing. And even if you have, I can see you don't use this in production. There's a lot of code, but if you have the tooling in place, you can compose those modules, right? And say this is what you're allowed to do, this is what you're not allowed to do, and this is what I expect you to use or in compute and in memory. And I think that's quite powerful. Let me get back to the slides. Because Niels, is that then a secure system? And then I need to talk a bit about runtimes and WebAssembly, because if there's a piece of software or runtime involved, stuff will still happen with that, right? And if you look at the security research that's been done, even with the first year I did this presentation, 2 years ago, I believe, if you look at Black Hat and DEF CON, those are the big security conferences that are held in August in Vegas. Most of the research were all focusing on like breaking out of the VM, right? Because this whole system can be as secure as the VM itself is. And I think even the last Black Hat, August, I didn't see much difference. There were still people who were able to break out of a VM, and that was it, right? But in technically things, the whole module isolation, all the stuff that I showed you before, that's definitely doing its work, right? But we need to make sure that the runtimes are secure. I think that's the goal. And the cool thing is that the Bytecode Alliance is pretty open about how they implement WASM time. There is a blog post where they talk about security and correctness. It's been written in Rust, and they use all the language features of it, right? Rust, you need to talk about ownership, and it's all about really explicitly all code paths that are covered, which makes it quite solid. And they also do continuous fuzzing, a formal verification. And they have a real process on if stuff gets disclosed. And I think even the people that were working on Hyperlight had disclosed some of the stuff. And it was nicely fixed, right? So they're pretty open about that. So this gives you the guarantee, like, hey, yes, we take this seriously, and these are the actions taken, right? And if you're like not a reader, there's also the person that runs it, Nick Fitzgerald, who talks about exactly the same bits and pieces in this presentation on WASMCon, right? So with this said, I think the key is it will be as secure as the runtime, and we need to still focus on keeping the runtime secure. I think that's the key take on it. in order for all the other concepts to work, right? In order for us to get the tooling right and to get all pieces in place. So let's wrap up, and then we definitely have time for questions. So I think in general, looking at WebAssembly, cloud native, doing modules, functions, serverless, right? Those things definitely, those are much more fine grained. I think Cloudflare does it with some loaders that they use on the edge that allow you to run WebAssembly modules next to the data where it's been stored. Fastly is doing the same. There are some cool startups. I think one of them is Fermyon. I think there were people from Dice Labs that worked at Microsoft that moved to Fermyon. You've got Cosmonic, who are creating almost like an operating system that's based on WebAssembly that runs on the cloud, which is pretty cool because they can just like, hey, you have this service and you're not necessarily interested in where it runs, but it will just be there. And there's a lot of cool stuff happening in that space as well. But we need to be aware of the fact that it will be as secure as the runtime, right? That will be the constraint. And as I said, Preview 2 was definitely something I was looking forward to, and in January this year it landed. Now hopefully the tools will get more into place. And as I said, the code that I showed, it's not like the stuff you're going to do in production, but there's a lot of potential. If you're able to model it in such a way and then make a build step of saying, like, these are the capabilities I want this module to have, that's it. I think that's the path forward. So we're going to open up for questions with like 5-7 minutes left. That's cool. The first one is the repo. As I said, the slides are not in yet because I forgot to do that this morning. If you want to reach me, that's my email. I'm on Mastodon. And I'm also blogging occasionally. I need to do it more often. That's why I put it on. I always confront myself. I need to do it more. And then I'm going to say, Tak, thank you for being here. Don't forget how to fill out the eval forms. And we definitely have got time for questions. So if there are any questions, let me know. Or if I just put too much information out right now, that might be the case as well. I'm going to be around until noon. I need to travel out this afternoon, unfortunately. But hope you enjoy the rest of the conference and see you around. Thank you. Go for it. Yeah. Yeah. I think you can probably write the same, yes, yes. But the compiler enforces certain things that will be reflected in that code that gets generated, right? The language constructs I talked about. So yeah, somebody could write that, yes. I'm not sure if you're happy with it, but it's doable. I didn't look into it, but yeah, it's this code, right? So yeah, cool. Thank you. Otherwise, I'm going to say enjoy and see you around. Thank you.